The next thing we're going to talk about then is going to be functions. We use this word a little bit, function this, function that. The idea behind a function is something is a function, we'll put it that way, is a function if for every input there's exactly one output. Okay? So think about the fact that anything that you use on a computer, computers use functions. So picture if you did your taxes and you put in all the information and it said, oh, you get a $1,500 refund. So you're like, sweet. Then you decide you just want to check it, so you put all the information in again, and it comes back and says you owe $17,000. That would not be fun. You put in the same input, so you put in your money, and it has the option. It'll either give you, that you get a $1,500 refund, or that you owe $17,000. That would be considered not a function. All right. So take something like x plus 3. X plus 3 is a function. If I give it an x value or an input of, say, 1, it gives me an output of 4. If I give it an input of 6, it gives me an output of 9. If I give it an input of 22, it gives me an output of 25. That's its only option. This is a function. Now something like this, plus or minus the square root of x plus 3. Now we've seen stuff kind of like this, plus or minus square roots or whatever. Now look what happens here though. Say I give it an input of x. It gives me an output of plus or minus 3. Plus or minus the square root of 9, plus or minus 3. If I give it an input of 13, it gives me an output of plus or minus 4. This is not going to be a function, because if I give it one input, 13 gives me 2 outputs, plus 4 and minus 4. So if I give it 13, it gives me 2 different outputs. This would be the equivalent of TurboTax telling you either owe $4 or you're going to get $4 back. Okay? So that's what we mean by functions. This is not going to be a function. Not a function. Luckily for us, there's some easy ways to tell when things are functions and when they're not. So we'll say this. Something is not a function if ... Now, for ordered pairs, so like XY kind of stuff. For an ordered pair, it's not a function if any x value is repeated. So if we see any x value more than once, you don't have a function. If you have a graph, just a graph, if any vertical line, let me try this again. I'm going to rephrase this. If you can draw any vertical line that hits the graph in more than one place, if you can draw any vertical line that hits the graph in more than one place, you might have heard this called the vertical line test. If something hits the line in more than one place, if it cannot pass the vertical line test, it's not going to be considered a function. All right? So let's look at some of the examples that we looked at before. I'll tell you right now that everything that we've done so far has been a function. So when we looked at 1, 3, 2, 5, and 3, negative 6, this here This is a function. This is a function. Every x is unique. Now, here's the deal. Every x is unique. It's perfect. That's the worst unique I've ever seen. Okay. Every x is unique. It's wonderful. The other one that we looked at 010, 120, 230, and 320. So is this one a function? Actually, yes, this is a function. Again, every x is unique. But you might say, well, wait a second, these y's are repeated. Does not matter. Absolutely does not matter. Y's do not matter. It has absolutely no impact. In fact, if you're doing these problems and you want to just scratch out the y's and pretend they don't even exist, go for it. If you want to scratch out the y's and pretend that they're not there so they don't confuse you, do that. Because then you can just look at the x's and say, okay, I've got a 1 and a 2 and a 3. Good. They're all unique. 0, 1, 2, 3. Good. Nothing's repeated. It is a function. So what if I went over here then and I wrote that a little bit backwards? What if I flipped them? What if I had 10, 0, 21, what was next? 21, 30, and 2, and my last point was 20 and 3. So is this going to be a function? Well, I don't want to get confused, so I'm going to scratch out all the y's. And I'm just going to look at the x values. Is this a function? No, this is not a function. The 20s repeat. The x's repeat. The 20s are x's and they repeat. Therefore, it's not a function. Got it? Okay. So let's look again at our graphs that we were using before. Okay? Now, like I said, everything we looked at in the last section, that was all functions, but let's just prove it. So we had a function that essentially looked like that, right, for that first example? So the question is now, does this pass the vertical line test? So whenever anyone asks, is this a function? I want to know, does this pass the vertical line test? Okay, so I just happen to have a handy-dandy vertical line I can hold along. So I've got my vertical line. I go, oh, how many times does it hit? How many times does that vertical line hit? It hits right here in one spot, right? Good. Okay. So let me grab it again. I missed it. I'm an incompetent vertical liner. So if I run it over here, anywhere that I run it, you can see that it's only going to hit it in exactly here. It hits it once. All along here, it only hits the line in exactly one place. As I follow the graph, the vertical line only hits the graph in exactly one place. So the question is, does it pass the vertical line test? Yes. It's a function. Okay? Yes, it's a function. We had another one that looked like that. It was the open circle one, and it went like this. Like that. So let's check this again. Does this pass the vertical line test? I start down here, only hits it in one spot, only hits it in one spot, one spot, one spot. It doesn't intersect anywhere except in that one spot along the line. So that means yes, it's a function. Running out of room. It's a function. Alright? So let's take a look at a different one. I had There we go. I had this one. I had my parabola going like this. Is this a function? Take my vertical line. It hits it in one spot, one spot, one spot, one spot, one spot, one spot. Even over here, it's still, even though it starts to get steeper, it only hits that graph in one spot, the spot that I'm at. Doesn't intersect the graph anywhere else. So I'm going to say yes, it's a function. I is a function. It's a function. So let's try something for funsies. It won't be a function. Let's take that same parabola and turn it on its end. Let's flip it to the side. So let's take this vertical line and test it. So I'm going to take my vertical line and I'm going to say, okay, doesn't hit it at all, doesn't hit it at all. Right here it just hits it in one place, hits the corner, but as soon as I hit pow, pow, and I'm going to pull it all the way out here so it's more obvious, but you can see right here, the vertical line hits it here, and it hits it here. It hits it in two places. So the answer is no, it's not a function. Alright, so now say I've got a function that, I already called it a function. Let's say I've got a graph that looks like this. Say I've got one that goes like this. I want to know, is this a function? I'll take my vertical line and I'm going to trace it. And as I trace it, I'll notice that that graph never hits that line in more than one spot. So since the graph never hits the line in one more spot, I can say yes, it's a function. But what if I take a very similar graph and I go like this, and I go do-do, 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 like this. Okay. I'm going to take my vertical line. I'm going to start to trace it. I'm good, I'm good, I'm good, and oh, I'm already done. I'm already done. As I come around this curve, you can see that vertical line hits the graph in three separate places. Now here I'm good, but it doesn't matter because when I get down here, it's just over. I hit it here, I hit it here, I hit it here, I hit it in three places, so no, it's not a function. You might say, well, wait a second, you know, like you just did that thing where you put the line there and it only hit it in one spot. Isn't that good enough? The answer is no. Remember back to our definition, way up here. The definition says if you can draw any vertical line that hits the graph in more than one place, it fails. So any graph in more than one place, it fails. So no, this one is definitely not a function. Okay. Now, I'll give you one more example that for some reason seems to blow people's minds sometimes. Up this one, a circle. Is a circle a function? Is a circle a function? So what you want to do, take your little vertical line, start running, look, it hits it in one spot, but oh, right away, it doesn't. It hits it in two spots. For some reason, people like to call this one a function. No idea why. This one is not a function. Got it? Not a function. Now, we can also ask you to tell us whether or not equations are functions. You might say, well, hey, that's not fair because, you know, you gave us a rule for graphs and you gave us a rule for points, but you didn't give us a rule for functions. That's true, but you do have your graphing calculator. So theoretically, you should be able to figure this out. So what do I need to do? If I want to graph this on my calculator, what do I do? Think about it. If I want to graph this on my calculator, I need to solve for y. I need to solve for y. Okay. So I've got this going. I'm going to subtract x squared off of both sides to solve for y. Y equals 4 minus x squared. Okay, so I can plug that directly into my calculator. Remember, I got that fabulous little y equals button? It's my calculator. I go to y equals 4 minus x squared. And I'm going to graph it. And I basically have a parabola. I have a parabola, right? Looks real nice. So that's what I can do, is I can make a little sketch. And it looks something like this. So does this pass the vertical line test? I take my vertical line and I go, yep. Yes, it's a function. Now I'm going to change one thing just a little bit. Instead of having, I'll leave it up there for a sec. Instead of having x squared plus y equals 4, I'm going to put x squared plus y squared equals 4. So I'm adding a squared right there. So if I want to graph this on my calculator, I got to get the y by itself. Got to solve for y. Start with the same basic process. Now, make sure you get this step right. Square root of both sides, right? But what do I need to put here? I'm going to put my plus or minus. So I've got y equals plus or minus square root of 4 minus x squared. Now this plus or minus right here should be your clue that something's wrong. Just like we had in the example at the very beginning of this discussion, if you have a plus or minus, you're done. This is already not a function, but I can prove it to you. The only way to plug this into your calculator is to break it up, to make a y1 equal to square root of 4 minus x squared, and to make a y2 equal to negative root 4 minus x squared. But already you've got that plus or minus, you know you're done. So I've either got, where's my square root button? I've either got the square root of 4 minus x squared, but I also have to account that I have negative square root of 4 minus x squared. And when I graph that, you'll see I've got top half and the bottom half of a circle. So we've got a circle, and we've already proven to ourselves that a circle, does not pass the vertical line test. But again, our first clue was this plus or minus. Once you got a plus or minus, you can immediately say no, not a function.